Hi everybody. Today, I will explain the different types in electric motors world as the follows. Electrical motor. The motor or an electrical motor is a device that has brought about one of the biggest advancements in the fields of engineering and technology ever since the invention of electricity. A motor is nothing but an electromechanical device that converts electrical energy to mechanical energy. It's because of motors, life is what it is today in the 21st century. Without motor we had still been living in Sir Thomas Edison's era where the only purpose of electricity would have been to glow bulbs. The primary classification of motor or types of motor can be tabulated as shown below. Electrical motor are mainly three types: DC motors, AC motors, special motors. Types of DC electric motors. There are four types of DC motors explained below. DC shunt motor. A shunt DC motor connects the armature and field windings in parallel or shunt with a common DC power source. This type of motor has good speed regulation even as the load varies, but does not have the starting torque of a series DC motor. DC series motors. A shunt DC motor connects the armature and field windings in parallel or shunt with a common DC power source. This type of motor has good speed regulation even as the load varies, but does not have the starting torque of a series DC motor. DC compound motors. The DC compound motor is a combination of the series motor and the shunt motor. It has a series field winding that is connected in series with the armature and a shunt field that is in parallel with the armature. The combination of series and shunt winding allows the motor to have the torque characteristics of the series motor and the regulated speed characteristics of the shunt motor. DC permanent magnet motor. Basic configuration of a permanent magnet DC motor is very similar to that of a normal DC motor. The working principle of any DC motor is same, that is, when a current carrying conductor is placed in a magnetic field, it experiences a force. A permanent magnet DC motor also works on the same principle. Types of AC electric motors. There are two types of DC motors explained below. Induction motors. An induction motor is an AC electric motor in which the electric current in the rotor needed to produce torque is obtained by electromagnetic induction from the magnetic field of the stator winding. Synchronous motors. A synchronous electric motor is an AC motor in which, at steady state, the rotation of the shaft is synchronized with the frequency of the supply current. The rotation period is exactly equal to an integral number of AC cycles. Types of special electric motors. There are four types of DC motors explained below. Stepper motors. Stepper motors are DC motors that move in discrete steps. They have multiple coils that are organized in groups called phases. By energizing each phase in sequence, the motor will rotate one step at a time. With the computer-controlled stepping you can achieve very precise positioning and door speed control. Servo motors. A servo motor is a rotary actuator or linear actuator that allows for precise control of angular or linear position, velocity and acceleration. It consists of a suitable motor coupled to a sensor for position feedback. Universal motor. The universal motor is so named because it is a type of electric motor that can operate on AC or DC power. It is a commutated series wound motor where the stator's field coils are connected in series with the rotor windings through a commutator. It is often referred to as an AC series motor. The universal motor is very similar to a DC series motor in construction, but is modified slightly to allow the motor to operate properly on AC power. DC brushless motors. Brushless DC electric motor, also known as electronically commutated motors, are synchronous motors that are powered by a DC electric source by an integrated inverter, switching power supply, which produces an AC electric signal to drive the motor. In this context, AC, alternating current, does not imply a sinusoidal waveform, but rather a bidirectional current with no restriction on waveform. Additional sensors and electronics control the inverter output amplitude and waveform and frequency.